Algebra 2, this is part of 2.2, section 2.2, but it's really more of a broader topic that we need to discuss as it relates to the notation that we need to learn to use regarding domain and range. Okay, I kind of mentioned this in my previous video and did a couple of quick examples, and we're going to just get a little bit more extensive here in that. The first is what's known as set notation. I believe in the previous video I might have called it standard notation. It's actually called set notation. And the one that we need to learn, especially for those who are pre-calc bound, I'm not sure what they do in college algebra, but for sure pre-calc teachers told us that we need to introduce interval notation in Algebra 2. So that is why this is here. When not directed, we would want you to use set notation. This would be better for when you are checking your answers on the Prentice Hall answer documents, because they're going to use set notation. But again, you need to learn interval notation. If we wanted it in interval notation, I would specifically ask for it that way. Okay, so I'm looking at a line here. I would have handed this worksheet to you already, so you should probably fill this out along with me. I'm looking at a line right here. That's pretty obviously that there's no interruptions. There's nothing that x can't be, and it's going to go forever. So this is basically negative infinity to infinity when we are using set notation. It's just all of the x's with no restrictions. Same thing with the y. That thing is going to go up forever and down forever. I know it feels like it's going more left to right, but infinity is infinity in both directions. So it's going to go to infinity this way as it goes to infinity this way, right and up. So again, just all y's, no restrictions, no inequality needed. Okay, and as the language I just used is, of course, negative infinity to infinity. That's what interval notation is all about. The parenthesis means you don't include that number, and infinity is technically not a number. Okay, so that's why they use parentheses, not a bracket. If you use a bracket, you'd be saying, hey, we got there. We got to infinity. You can't get to infinity, though. But that's what this means, and it's in both domain and range for the line. This next one, coincidentally, is similar to, or maybe it's exactly the same example that I used yesterday or in the video prior to this one. So I just went ahead and filled those in too. There isn't any x that this can't be. Y, however, is greater than -2. Here's -2. It never gets below. It's all above. So this is how we express that. We say the variable y, and then we section it off, and then we use an inequality. Now again, since this is the same as it was above, right? These are going to match. These are going to match. Negative infinity to infinity. But for interval notation for this parabola, it goes from -2 inclusive, that's why this bracket is here, through infinity, starting here and going up. Okay, so let's start to fill the rest of this out. Looking at number 3. Again, there isn't anything that x can't be. There's no breaks, no lines that this thing approaches but never reaches. That's called an asymptote. We'll talk about those later. And it's just continuous. It's just continuous from left to right forever. So again, we're doing this. And in interval notation, again, we're doing this. Okay? But look at what happens with the y. It goes down as far as -2. It goes up as high as 5, and it can be any point in between there, right? And then this runs along 5. This runs along -2 forever, as we would interpret those arrows to mean. So here you'd go y, and then use an and situation inequality. -2 less than or equal to y less than or equal to 5, like that. Okay? And in interval notation, it's just inclusive of -2 and 5 and everything in between. The way we do that is with the bracket, -2 to 5. Okay? Looking at number 4. This is what we'll call an ellipse. And looks like it goes from, in this case for x, from -4 to +4. The way we do that is like this. X, -4, less than or equal to x, less than or equal to 4. I'm trying to write as small as I can here and show decent looking brackets. Whereas y, here I'm going to put it underneath just to give myself a little more space. Y looks like it goes to -8. That is -8. This is +8. Sorry if you had trouble counting to that, but that's what it is. It's a little blurry on my screen here. And that's what you would do in set notation using inequalities. And again, with interval notation, a lot of times it's easier. It's just -4 to 4, -8 to 8 with brackets. -4, comma 4, -8 to 8. Okay. What about the next one? That's kind of interesting, isn't it? There's no kind of minimum to maximum to get to. There's really just one number. It's 6. And do you remember, like when we first introduced domain and range? That's what we did. We just listed all the different elements. If there's a finite number of them, and it's not a terribly long list, you can just list them. And that was in the previous video. So for this, it's just 6. But the line extends up forever, down forever, so that would be all y. Okay. Now, for interval notation, I'm not 100% for sure what you're supposed to do. I have two educated guesses. One would be this, and the other one would be this. And I'm not sure which one. I think I would accept both. Okay. It's late on a Friday afternoon, and the people that I would go to ask this are not here anymore. So I would lean towards this one. That'd be my first guess. This would be my second guess, and then all bets are off after that. Okay, but anyway, it's -infinity to infinity. All right, and one more, and I find this to be the most interesting one, especially coming out of what was section 1.5 when we did the and the or situations with the inequalities. Pay attention to this one, because the points that are along these two branches of this graph. By the way, this is called a hyperbola. That's the kind of graph this is. You have parabola, you have ellipse, you have line. This is hyperbola, and the points that are on this branch would not be on this branch, and the points that would be on this branch would not be on this one. And this is kind of mimics the or situation where the graph was on the number line was going away from each other, right? You'd have circles and then shade one way and a circle and shade the other way on a number line. So this is what this looks like for domain. This is x, where x is less than or equal to -3, or x is greater than or equal to 3. And again, I'm going to put the range down below so I have enough space. Okay. It's either less than or equal to -3 or greater than 3. It's not and. No number is greater than 3 and also less than -3. It's or. The or is the right way to say it. Okay. And then, well, actually, the domain is small anyway, so I could have fit it there. But anyway, it's just all y. I mean, the range is small. Okay. Now, last thing, and this is important. When we have two branches like this, when we have a break from one to the other, and we need to list this, we're going to use what's known as a union. Okay. And it's real easy to remember because it just looks like the letter U. You're going to say -infinity to 3, inclusive with the bracket, in union with a bracket that goes from 3 to infinity, like so. Okay. Now I could get more into explanation of this union, but that could actually get really long. So I think you should just probably, the wise thing to do would be to just adopt that terminology, and we'll live to fight another day to get the explanation of why that's in union. Okay, but that's what it is, and that's the correct way to express the domain for this situation. And then the last part is just going to be -infinity to infinity. All right, thanks for watching.